this video, we are going to be diving into an incredibly exciting topic. Can artificial intelligence solve pharmaceutical calculations questions? And we are starting right now. Hello, this is Dr. Danquah. And if this is your first time here and you like to learn pharmaceutical calculations, tips, tricks, and strategies, then start by subscribing and clicking the notification bell so you don't miss anything. So let's get right to it. Now, to bring this discussion to life, we will be demonstrating with the aid of Bevinzey, which is a powerful AI-powered learning platform, and we'll be focusing on Milliequivalents calculations. Now, as a quick reminder, Milliequivalents are a chemical unit that measures the chemical combining activity of an electrolyte, and the Milliequivalent expresses the concentration of electrolytes in solution and is calculated as the product of the millimoles and the valence of the electrolyte. Now, understanding Milliequivalents calculations is crucial as it is one of the calculations topics on the NAPLEX board exam. It's also important in clinical practice. Now, if you need an in-depth video tutorial on Milliequivalents calculations, I do have several videos on the channel, and I'll put links in the description as well as link it in the cards. Now, for this tutorial, we're actually interested in determining whether you can actually use artificial intelligence to solve pharmaceutical calculations questions. And we're going to be using Milliequivalents as the topic of choice, and we are using Bevinzey. Now, Bevinzey is an AI-powered learning platform, really powerful. Now, to get to Bevinzey, you just need to type in bevinzey.com. It's going to pull up this homepage, and I'm already logged in. And what we want to go is go to services, and there are several models. This is a powerful learning platform. It can do so many other things to help you skyrocket your learning strategies. But what we want to do today is click on the chat Bevinzey, and you're just going to copy a number of questions and find out whether the AI platform can actually solve them correctly. So just so that we have a very good basis, I'm going to be using the question bank. Now, Bevinzey is an AI-powered learning platform which I developed with my team, and I'm going to put a link to a discount code in the description just in case you want to check it out. But like I said, to make this a fair comparison, I'm going to go to the question bank. You all know the NAPLEX Question Bank, which we developed several years ago, but it's still very helpful for many students. And I'm going to go to the Milliequivalents calculations section. So we're just going to navigate real quick to Milliequivalents. So in here, we're just going to pick the untimed, and we'll look at a few questions. All right, so I'm going to start the quiz, and there are several questions in here. I'm just going to copy the question. We're going to see what the AI-powered platform tells us, and we will check it with the step-by-step solution that I actually did to answer this question. So let's just copy this. I'm going to go in here. I'm going to just paste it. Nothing fancy. Just paste it in there, and then we're going to have the AI analyze the question, and then it's going to generate an answer. Then I'm going to check it based on what I solved, whether the answer is correct, and what approach that you actually used. So in this question, we're talking about a 20 ml dose of potassium chloride. The elixir has a concentration of 25% weight by volume. How many milliequivalents are represented in this elixir? Round to the nearest whole number. Do not include units. So it's not really a straightforward question. It's also not too complicated. So let's see how the AI did. So I'm going to click check, and let's see. Well, the answer is 67. What was the answer here? 67. I guess it actually got the right answer. So it walks you through the process, and just to make this really actually more detailed, I'm going to quickly go to the solution, and let's go all the way to the end. All right, so there are a number of things that we want to actually compare. Generally speaking, this is a very nice equation to use. MEQ equals weight of substance in milligrams divided by molecular weight times the valence. And so important thing is we should be able to have the valence correctly, and then also be able to compute the molecular weight as it was not given in here. And I properly put in the right amount of the substance in milligrams because we are given a percentage concentration to be 25%. So let's see what the AI did. Yeah, actually went ahead to calculate the molecular weight or the molar mass. So that was excellent. That's correct. So it was also able to accurately determine the valence to be 1. So the valence is 1, which is important. Now let's look at the solution here. We do have a valence of 1. Now, by the way, the valence is going to be the absolute charge on either the cation or the anion, because you do have the potassium chloride is an electrolyte in an aqueous environment. It's going to dissociate into a potassium cation and a chloride anion. So the valence is the charge on either of those ions, the absolute value. So we do have 1. Now, the other thing that was really really curious to understand whether the AI could do is actually understand the fact that what we have is a percentage concentration, and that you have to use that concentration in conjunction with the volume to determine the amount of the substance in milligrams. So when you look at the solution, it really does that really nicely. It actually takes the 25% weight by volume. It knows to convert that to milligrams, and that's the actual subheading here. Now let's convert the 25% weight by volume to milligrams. That's important. The important thing here is actually the logic that it is using. So even though it doesn't use exactly the same equation as I did in the step-by-step video solution, it actually is able to still encapsulate the thought, right? So it takes the 20 ml and then it actually converts the percentage concentration into a more appropriate form. It does it to 250 milligrams per ml. So it gives us 5,000 milligrams. Now what do we have? We also had 5,000 milligrams right here. So it used a different approach in some ways, but it still followed the right logic to solve the problem. And so now when you look at the final answer, it has 67, follow the directions, round the nearest whole number, 67, and we also had 67 as well. All right, so that was the first question. Let's try a different one. Maybe it got lucky. So let's try a different one. So this may be fairly straightforward. We could try that as well, but let's see whether we can find something a little bit more tricky. But we'll do this one. So I was able to solve this in, I would say, about 10 seconds, 15 seconds. And the answer I got was 0.65. Let's also check that. 0.64, 0.65 is about the same. There may be some rounding differences, but clearly it's actually able to get the logic. All right, so let's see. We went through the question. What do we have? The question says, if 1.92 grams of potassium chloride is used to prepare 200 milliliters of a solution, how many milliequivalents of potassium ion will be in 1 teaspoon? Round to the nearest 100. Do not include units. So although it's fairly straightforward, it really involves some thinking process. You first need to understand that you need to convert the grams to milligrams, and then you also need to understand what the volume of a teaspoon is, and you also need to determine the valence and molecular weight. So we already know that the AI can actually, do the valence, but let's find out whether the AI can actually reproduce that. So we did calculate the molecular weight, then we went ahead to use first principle, to correlate the valence and the quantity. So the MEQ in 1.92 grams of potassium chloride was determined to be 25.76. So if you actually compare the solution, it's going to look different, but it's actually the same because we're using the equation, and here the AI actually chose to use first principle, which is about the same, just a different way of capturing the whole computation. And so if you follow this logic, it's going to tell you that you have this much of 25.76 milliequivalents of potassium, and then it tells you that that amount is in the volume of 200 milliliters because that's what you prepared. But the thing that is really nice is it was able to understand that we are more focused on a teaspoon, 1 teaspoon. So it was able to actually tell you how much is in the teaspoon. So that's impressive right there. And if you follow the solution in the step-by-step video I created for the question bank, then you notice that the logic is the same. And so that's how come the answer is about the same. So there's just some slight rounding differences, but 0.64, 0.65 is exactly the same. So that's 2 out of 2 for Bevinzey. Let's check another question. All right, so let's find out whether it can understand what half normal saline is. So how many MEQ of sodium are in 3 liters of half normal saline? So it's fairly straightforward, but the term half normal could throw the AI off. So let's see. And this was actually rather expeditious. The answer came really quickly. It has 231. Let's see what the answer is right here. 231. I mean, that is 3 out of 3 for the AI. Really, really smart. So normal saline contains 154 MEQ per liter of sodium. So half normal saline has half the concentration, which is going to be 77 MEQ per liter. This is just brilliant. I mean, that is something that you would expect a pharmacy student or a pharmacist to know. And so it's actually good that the artificial intelligence can capture that and then call on that and use it when it's needed. So the answer is correct. Not much to delve deeper in there. And if you check the solution that we offer, you do end up with the same answer. Just go through slightly more extensive steps so that you can actually follow the logics. So when you look at the solution that we provide, the step-by-step video solution, this is actually maybe more easier for students to understand, but clearly the solution from the AI or from Bevinzey was much, much shorter. Now this actually implies that you can follow the logic, and the logic is really straightforward. Once again, identifying what half normal saline is and simply multiplying that by the volume in liters. That's completely straightforward and easy to also understand. But here what we're doing is we actually using the equation. Most students like the plug and chug, so you simply put in the values and then you arrive at the answer. So it gives you complementary solution, gives you the right solution, and right now we are 3 out of 3, 100% for the AI. Let's try another one. So let's see this one. This is slightly different. So this gives 115. 115. This is just fantastic, So here we have a slightly different question. You have an intravenous parenteral nutrition solution which contains 75 MEq of sodium chloride and 40 MEq of potassium chloride. How many milliequivalents of chloride are being provided round to the nearest whole number? Do not include units. So what a powerful statement. It says the chloride content will be equal to the sum of the milliequivalents of sodium chloride and potassium chloride, since both compounds dissociate completely in solution and each of them has one chloride ion. That is the actual essence of the question. So once you understand that, the solution becomes really easy and straightforward. So it's really impressive how the AI could do that. And once again, even though this was slightly different, you don't need the equation here really. Let's see what we do here. So here actually go step by step, and of course we are explaining and teaching, so you want students to understand where all of the logic is coming from. So that's why it looks a lot of writing. This right here where you have the molar ratio explains that you have the same number of moles of chloride as you do have sodium chloride, and that's what this first sentence is actually telling you. Because milliequivalence is millimole times valence, if the moles are the same and the valence is 1, then the MEq will be the same. And so the answer is correct here, but it assumes that you understand all of this concept. So, and they just need to mention this, can the AI really replace your professor? Probably not, because you still need to be introduced to the concept and have some in-depth understanding, which may or may not be given in the solution, or if it's given the solution, you should be able to correlate that to some background which you have already previously studied. So that's something to keep in mind. But as of now, we have done, I think, 4 questions, and it's 4 out of 4, so 100% for Bevinzey, 100% for AI. So let's try another one. Maybe we'll do 1 more or 2 more questions and then we'll wrap this up. All right, so let's try this one because this has quite a few percentages in there. So the answer was 200. Let's see what the answer is here. 200. My goodness, this is fantastic. So it's 5 out of 5 for AI and Bevinzey. Let's see what the question is. 450 ml vials of sodium bicarbonate with a molecular weight of 84, it gives you the percentage concentration, are added to 5% dextrose in water as an IV solution. How many milliequivalents of sodium are contained in this solution? Round to the nearest whole number. Do not include units. So here we have the solution. Here we use the equation because, once again, it's a really convenient way to go about it. Now, what are some of the things we want to identify and find out whether the AI was able to process? First of all, was the AI able to understand that you have 450 ml vials, which would influence the total volume that you have? That's the first thing. The second thing is you have 2 percentage concentrations. Can the AI distinguish between the concentration of the sodium bicarbonate and also understand that the 5% dextrose is simply a large volume parental, which is going to be like your vehicle in which you're going to put the sodium bicarbonate. That's important. So when we check the solution, it says first we need to calculate how many grams of sodium bicarbonate are in the vials. Now, based on this statement, first statement, it means he actually understood the fact that you need to figure out how many milligrams ultimately are in 450 ml vials, which is 200 ml instead of just 1. Most people will miss that. So here we see it does a really nice job. 4 times 4.2 gives you 16.8 grams. When we did ours, we ended up with 16.8 grams right here, and then we converted to milligrams. Let's see how the solution unfolds. So here again, they proceed in moles, which is slightly different from the approach that we did, but ultimately gives you the same answer because at the end they multiplied by 1000 to get MEq instead of simply equivalents, and we went through with the equation and still ended up with 200 milliequivalents. So it's impressive, actually, really impressive that the AI can understand to do this. And as of now, we did 5 questions and it's 5 out of 5. Maybe we do 1 more. Let's find a real tricky one. Yeah, this could be a tricky one. And let's find out whether the AI could do it. And if it encounters an issue, I'll tell you why that will not be surprising. But let's find out. So once again, in about 10 seconds, is able to generate an answer. Let's check what we got. 19.6 MEq. This is just amazing. Now, the reason I was saying it could be tricky had to do with the valence, but let's look at the question. So how many milliequivalents of potassium citrate is represented in 2 grams of anhydrous potassium citrate? Round to the nearest tenth. Do not include units. And so it's on the surface a really short question, but the real thing was understanding the valence. Here you have potassium citrate, and in potassium citrate, although the valence of potassium is 1, you have 3 of it in there. So when it dissociates, it's actually going to be having a valence of 3. But let's take a look at the full solution right here. So in the solution that I actually developed for the question bank, we using the equation once again, and we first need to determine the quantity in milligrams. Now here's where the kicker comes in. So for valence, when you look at the valence, you have C6H5K3O7. And when the potassium citrate dissociates in an aqueous environment, it's going to give you 3 potassium cations, and then you have the citrate anion. So the valence is 3 in this instance and not 1, because once again, the valence is the absolute charge on either the cation or the anion. So the absolute charge here for the anion is going to be absolute of -3, which is 3, or the absolute of 3 times +1 for the potassium, which is going to be 3, and the valence will be 3. Now, if you need more tutorials on Milliequivalents, once again, I'm going to put links in the description, and I'm also going to link it in the card. So just check those out for a review. But now let's see exactly how the AI did right here. So I like the first sentence right here. Potassium citrate gives you the molecular formula. It's with 3 potassium ions per molecule, and then also gives the molecular weight. Right, so it calculates the molecular weight. It tells you that you have 3 potassium ions, which means you have a valence of 3. And then it goes ahead to basically solve the question in a slightly different fashion, but still ends up with the same answer. So we did 6 questions and it got 6 out of 6, which is a perfect score. So let's just evaluate what just happened. We went through 6 questions. It got all of them correct. Now, the thing about the AI or Bevinzey, it did not only just give the final answer, but also explained step by step in its own way how you arrive at the answer. And mostly it solved it from first principle, and I'm sure if we indicated for it to use the equation, I'm sure it would have been able to do that as well. But it's really impressive that it can actually solve them correctly. So at least we do know that Bevinzey can solve Milliequivalents calculations for sure. Now the question then becomes, can artificial intelligence solve pharmaceutical calculations? Well, absolutely, for Milliequivalents calculations. Now if you'd like to see how Bevinzey works for the other topics like osmolarity, flow rates, and so on, then put a comment in the comment section and I'll just make a video for each of those topics showing you how well Bevinzey performs. But clearly for me, it's very impressive. So now let's answer the interesting question we talked about at the beginning. Can artificial intelligence solve pharmaceutical calculations? Absolutely. At least we know that the AI here, or for Bevinzey, can solve Milliequivalents calculations. We do know that for sure. Now, if you want to see how the AI performs or how Bevinzey performs for other calculations topics, such as osmolarity, IV, flow rates, reconstitution, and so on, then just put a comment in the comment section and I'll do the videos for each of those topics showing how well Bevinzey performs. So if you would like to check out Bevinzey for yourself and dive into it some more, then you'll find a valuable coupon code in the description which you can use to get an unbeatable prize. So I hope you found this video tutorial useful. If you did, be sure to like it and share it. And if you have any questions, leave them in the comments and I'll get to them as soon as I see them. If you'd like to learn more calculations, tips, tricks, and strategies, then start by subscribing and clicking the notification bell so you don't miss anything. Thank you so much for watching, and I'll see you in the next video.